All right, guys, last topic for the day. This is topic 4. Find the average rate of change of a function. Average rate of change. What is the average rate of change? It's basically just the slope. Let me draw you a little picture, illustration. So let's say I have some function, yeah? Function, where am I gonna draw this? Let me just use this space right here. So let's say I have some function. Goes up and down. But I want to know, okay, from my starting point A to my ending point, let's say somewhere, I don't know, over here, let's say B, this is some interval. What is the average change? So look at that thing, it went down, it went up, it went back down. But overall, what's the change? Well, it's just the slope from here to here. That's the average rate of change. The change is the gap from here to here, right? From here to here. This is the total amount of change, right? So, and this is how long it took. From A to B is how long it took. So what's the rate of change? It's just how much change happened, this up and down motion, divided by how long it took to get there. So in other words, it's just the slope of this line between the 2 points on the function. And slope we knew how to do before, right? Remember? So if this A is point x1, y1, this is point x2, y2, then the slope, remember, from whatever section we covered it in, was y2 minus y1 over x2 minus x1. And all that is the vertical change divided by the horizontal change. The rise over the run, right? So think rise over run. That means if you want the average rate of change between 2 points of a function, a and f of a, this is just like your x1, y1, and b, comma f of b, x2, y2. Then it's the same thing, right? This is like your y2 minus y1 over x2 minus x1. But why do they use those a, b, and all that stuff? Well, because that's kind of like just using the function notation, right? Let's draw that same picture again over down here. Similar picture. It won't be exactly the same. Okay, so I have some function, right? This is my function f of x. So looking at my starting position, if the x-coordinate is a, then the y-coordinate is the function value at a, f of a. And then my ending position here. If the x value is b, then the y value is f of b, whatever the function value of b is, right? And then you just calculate the slope between those two. That slope is your average rate of change. Okay, there's an alternative format. This is, this format, they kind of show it to you because later on this becomes important when you take calculus, this concept or this exact formula. But it's really just the same thing again, just written a little bit differently. So let me illustrate you what's happening here. This is called the difference quotient. You have that same kind of picture here, right? Here's A, here's B. But instead of looking at A and B, you're looking at it as, okay, this is my x value, whatever x value is. And then this is x plus h. So this is something that happens later on, h away. H is just the distance between these guys. It's this gap here. That's h apart. And what is the that's this bottom part, right? That's the run. What is the rise? What is this rise? Well, this rise would be, okay, this height here is f of x, right? And what about this height here? This is f of whatever x plus h was. So that means using the same old formula again, all over again, you get this. F of x plus h, this is like the y2 minus y1. Oh my gosh, sorry, those terrible y1. y2 minus y1 again, right? This is the y2, this is the y1. And then over here, the h is the result of taking x plus h minus x. It's just the gap between them, the run, right? That's all it is. So another way of saying the same thing. Okay, on to the questions. We've got 1, 2, 3, 4, 5. So number 14. For the new Lamborghini Huracan is valued at $250,000. And 5 years later, it's valued at $110,000. What's the average rate of change? So here, okay, let's just identify our points here. this is like your starting value, right? So your y1 basically. This here is like your y2. This here is the difference between x2 minus x1. It's telling you the difference. Or if you want to use different notation, it's up to you, right? Like this is the slope notation. If you want to think of it as this is your starting point A. This is your starting point B. I mean, ending point B. This is going to be f of A and f of B, right? Is that why I said it on here? Sorry. Yeah, f of B and f of A, right? The function value at the starting point, function value at the ending point. And then 5 would be just the result of B minus A. So what is the average rate of change then? It's just the ending value, 110,000, minus the starting value, 250,000, divided by how long that took, right? It's the rise over the run. This is number 14 here, by the way. And fun fact for you guys, my brother actually bought a Lamborghini, not as like an investment, so he's like he rents it out, so it's kind of like a little side business. But yeah, interesting fact. Okay, and then so yeah, you just subtract 5 by 5, and then the result. So the result, I'm not really good at doing this kind of math stuff, so I'm just gonna cheat and plug it into my calculator. Okay, so 110,000, I'm just typing it in and telling you as I'm writing it, minus 250,000 is negative 140,000. Okay, and I take that number and divide it by 5. Okay, so this is going to be negative 28,000. So negative makes sense because it's decreasing in value over time, right? And 28,000 is the decrease per year if you were to average it out. Okay, great. That was 14. Oops, I meant to erase. That was 14. Okay, now on to number 15. So number 15 is more of a, wait a minute. Something is missing here. Let's go back to the question. I think I missed something. There's some missing information here. It should have been given an interval. Yeah, that's something I gotta fix with the notes later. Let me see if I can maybe I should just make something up. Or see if there's a given value here. Sorry guys, hold on 1 second. Let me figure out should I just make something up, or should I give you? Yeah, okay. I'm just gonna make something up. So I forgot to give you guys intervals here. So let's just say, let me add an instruction here. This will be in the notes. Once you see it, then this will have already been added here. But let's say something like for questions 15 to 17, let A equal, I don't know, 1, and B equal, let's do something easy, 2, 1 and 2. Okay, so A will be 1, B will be 2. So average rate of change between the interval from 1 to 2. Okay, this would be 1 to 2. This would be 1 to 2. Okay, sorry about that. So now we're at 15. Let's do 15. So how do we do this? Well, we're using this idea, right? We got f of b, the ending point, minus f of a divided by b minus a. So in this case, what is f of b? Well, that would be f of 2, right? Which is 3 times 2 to the second minus 5 times 2 plus 11 equals 3 times 4 minus 5 times 2 plus 11, which is 12 minus 10 plus 11, which is 12 minus 10 is 2 plus 11 is 13. Okay, so that's the f of b. This part is going to be 13. Okay, let me just do it in the bottom. Okay, now f of 1, it's easier. 3 times 1 squared minus 5 times 1 plus 11 is equal to 3 minus 5 plus 11. 3 minus 5 is negative 2 plus 11 is 9. Okay, so now we're all set up to do the final calculation here. This f of b minus f of a divided by b minus a, this is going to be 13 minus 9. And b and a is 2 and 1. 2 minus 1. Okay. So that here is going to be 13 minus 9 is 4. 2 minus 1 is 1. So the average rate of change is 4. Okay, that's 14 done and 15 done now. Oh! Okay. Maybe erase it the slow way. I think because I just overlapped my selection box with the other box that I copied pasted earlier. Okay, 3 more to go, guys. 3 more to go. Number 16. This time p of x. Remember, there's nothing sacred about using f. Doesn't have to be f. P of x, same deal. Doesn't even have to be a x in there. So p of x equals x to the third. We're again using this form, right? We're using f of b minus f of a over b minus a. And here in particular, we have f of 2 minus f of 1 over 2 minus 1. Except I just realized I'm not using f, I'm using p, but same thing. Let's replace those with p's. All right, let's do p of 2 first. That's going to be 2 to the third, which is 8. Easy. Now let's do p of 1. That's 1 to the third, which is 1. Oh, okay, it's an easier one. So that means when I go to do this guy, it's going to be 8 minus 1 over 2 minus 1, which is 7 over 1, which is 7. So average rate of change is 7 on that interval anyway, from 1 to 2. Okay, sweet. 16 done. Okay. 16 is done. On to 17. H of x is 9 over x. Again, on the interval from 1 to 2. So we're looking at average rate of change is h of, ooh, I like this pencil. H of b minus h of a divided by b minus a. In this case, we're looking at h of 2 minus h of 1 divided by 2 minus 1. So let's do our side calculations here. H of 2 is 9 over 2, 9 halves. Okay. H of 1 is 9 over 1, which is 9. Okay. So let's plug those things in. 9 halves minus 9 over 1. 9 halves minus 9 is going to be, it's going to be 9 halves minus 18 halves. So it's going to end up with negative 9 halves on the top over 1. And 18 divided by 1 is itself, so negative 9 halves in the end. So negative 9 halves. That's the average change from the interval, on the interval from 1 to 2. Okay, that's done. That was easy. Okay, one more. Almost out of here. Almost out of here, guys. Okay. Last question. Let's go back to that pencil. I like that pencil. It's number 18. Makes my handwriting look slightly better. So I've got this function y of t. This looks like a physics equation for like something, an object that's falling, or that's shot to the sky or something. Because this negative 16t squared looks like a acceleration to me. Anyways, so you got this thing, right? And we want the average rate of change from 0 to 2. So I'm looking at t of b minus t of a over b minus a. Here, is t equal to 0? That's the a. And b is the 2, right? So I've got t of 2 minus t of 0 divided by 2 minus 0. Okay, let's do a side calculation now. T of 2 first. 120 plus 8 times 2 minus 16 times 2 squared is 120 plus 16 minus 16 times 4. Again, I'm just going to plug into my calculator, plug in chug like my middle school math teacher used to say, Mr. Corcoran. And that's 72. 72. That's t of 2. Okay, what's about t of 0? Easy. 120 plus 8 times 0 minus 16 times 0 squared. And you're just left with the 120. So you started off at 120 height and dropping down. Yeah, this formula is like I said, this looks like the formula of something dropping. Okay, so let's plug these numbers in then. So I've got 72 minus 120 over 2. I'm just going to plug it in. So 72 minus 120 is 48, and then divide by 2 is 24. But that's negative, yeah, negative 24. Negative 24 because it looks like probably an object is dropping. It's decreasing over time. So negative 24 is my average rate of change. And there we are, guys. All done. All done. Sweet. All right. Have a great week. Have a great day. I will see you in the next section, guys. Peace.